So if you're taking calculus in college, there's no calculator I would recommend more than the fx-CG50. For why this calculator is so good, we'll get into. But for calculus, if you do decide to get this calculator, I highly also recommend that you get this calculator as a little sidearm, because this one does more elaborate math. This one is more quick math. Like if I want to know what sine of 1 radian is, okay, it just spits it out quick for me. This, it would take a little more time because you'd have to go to run matrices sine of 1, right? Like you could do that. But for practical purposes, it's just good to have one that you can do quick on, one that you can just graph things on. And that's the whole idea. In calculus, you're going to learn many things. And it's going to be 1, the derivative, and 2, the integral, at least in a Calculus 1 course. Now, this specifically is helpful for integrals, I found, more than derivatives. Finding the slope of tangent lines isn't as easy. It's not going to give you just a formula. It can give you slope of a tangent line, but never a formula, which is usually what you do. It's like find the equation for the slope of the tangent line. That's what it asks you. Normally, you're not usually asked to find, okay, what actually is that slope, right? So, and there's a ton of cool features on this that will help you later down. Let's say you get into Calc 3 Diff EQ. There's some more extra functions here. Another cool thing, if you're like me and you are a chemistry major, I'm specifically in biochemistry, they actually have a periodic table on here and a just constants and stuff. So like, let's say universal, let me find one. That's constant G. See, I don't know much of these because I'm just a, the speed of light, C, the speed of light, in meters per second, right? So kind of cool what this calculator has. I never really dabbled with the 3D graphs or probability or geometry, but there's a lot to this that could help you. You just have to learn how to use it. But specifically for calculus, and where I find most of you guys will be is in the graph section. And something very important is when you're doing integration. Specifically, let's take the curve 2x. So to type that in, no, not 2w. I guess we could make it as a function of w, but we hit alpha, and you can see the red ones here correspond to variables. So x is where the plus button is. You can see there's a bunch of other options. You can do imaginary numbers, pi, and there's also our transcendental functions like sine, cosine, tangent, ln, log, e of x, 10 to the power of something, right? So pretty simple. There's a lot, like I'm just learning this calculator. I'm quite literally in Diff EQ, so I just finished Calc 1 and 2, moving into Calc 3 and Diff EQ. But to get back to what I was saying, if you're in college, just entering college calculus, here's something interesting you can do. So let's take these graphs. So 1/2, or sorry, let's just go with x squared for now. We're not going to go too fancy. So we have these two graphs, y equals 2x, y equals x squared. Now if we hit draw, this draws a curve for us. Now in calculus, let me zoom in here. So if you hit zoom and then in, you can kind of show where you want to zoom into. So I want to zoom in here. An idea of calculus that you're going to learn is finding the area between two curves. So imagine this area here enclosed by these two curves. So what is the area of this region? This is helpful just in math in general. You'll find a gazillion applications for this in physics, in even like graphic design, 3D graphic modeling. You could do that by revolving it maybe around an axis. It's really cool what you can do in calculus, but sorry to blow smoke up calculus's ass. Let's get into some cool things. Now, there's going to be a couple ideas that you're going to learn. The first one is that area under a curve, or between two curves. Now, this requires an idea of finding the bound regions, and that requires finding where the curves intersect. This is actually really cool. If you go over here to G-Solver, you can find minimums, maximums, y-intercepts, intersection points, And we'll get to the integral here, which is finding the area of a curve. But if we hit intersect, you can actually see the intersection points. It tells you 0, 0 is an intersection. That should make sense. You set the functions equal to each other. When does one function equal another function? Well, divide x squared by 2. You're going to find out that one of the solutions is 0, 0 because you factor out an x. And at this point here, at x equals 2, there's another intersection point. So pretty cool stuff that you can do here. But let's build on this. The integral. So this is actually what you're going to be doing. A lot of in calculus is doing integrals between two curves to find the area enclosed, or maybe just the area under one curve. You can use an integral function. You just go to GSolver, you go over, and you hit the little integral with respect to x, right? So basically, you can pick between roots, basically between zeros. In this case, that wouldn't work here because it only crosses the axis once. Intersection, which is what we're going to look at. Mixed is a more very complex way of thinking about it, or just a integral of just a function. So if I wanted to find the area under the curve of this whole region here for like our linear curve, that could work. But we're going to go with the intersection to actually find the area between these curves. Now, if we hit the enter button here and we go like this, we select the intersection points, which is what we found, 0 to 2. We hit enter and it graphs it out, and we find out it's 1 1/3, so 1.333333 repeating. And it tells you the lower bound is 0, the upper bound is 2, and the area between those curves, it gives you right there. It also will give you a absolute area or just a regular one, because if we had area in the negative axis, this would decrease the number. But an absolute area sometimes is better because you don't really care about the negative axis and you don't want to do any manipulation to make it represent that. So pretty simple here. I just thought this is a really nice calculator from the years that I've had it. I actually got it for Christmas. It's about $100 and something, and it does a wonderful job, a lot better than a TI. I've noticed like this has saved me on a test one or two times. Like you'll think to yourself, did I do this right? Did I do this integration right? Did I set up the problem in the correct way? And this can double check your work. So I think it's very helpful, and I hope that you guys bring some value out of this if you're considering getting it. Thank you very much. Bye-bye.